All right, topic for today is mathematical patterns. All right, we're going to say that if the numbers in a list follow a pattern, all right, so if the numbers in a list follow a pattern, you may be able to relate each number you may be able to relate each number in the list to its numerical position in the list with a rule. If the numbers in a list follow a pattern, you may be able to relate each number in the list to its numerical position in the list with a rule. A sequence is an ordered list of numbers each number in the sequence is a term of the sequence. All right, so look, here's what we're kind of talking about here. If you've got a sequence going on, let's say that you got a 2, 4. All right, here's a sequence of numbers, 2, 4, 6, 8, 10, dot, dot, dot. All right, that's a sequence of the even numbers. Now, what they're talking about, term number and whatnot, this 2 is the first term in the sequence, and the 4 is the second term, and so on. All right, and when you're referring to sequences and terms, you use the letter A, and you use subscript. All right? And in this case, if we were talking about A sub 5, we're talking about the fifth term in this sequence. All right? So the fifth term in this sequence is 10. Now we're going to talk about a couple different formulas that you can write to represent these sequences. So there's two types of formulas. There's an explicit formula. Describes the nth term in the sequence. An explicit formula describes the nth term in a sequence. Using the number n. Explicit formulas nope, not yet on that. So back to this example right here. If you were going to write a formula to express this sequence, you could say that a sub n is equal to 2n. Because look, in this a sub n equals 2n, if you replace the n with a 1, then what you get is your a sub 1 is equal to 2 times 1, which equals 2. And your a sub 2 is equal to 2 times 2, which equals 4. All right, so this would be an explicit formula that represents this sequence. Because if you wanted to know any term number in that sequence, all right, you wouldn't have to continue the sequence and count terms. You could just substitute. If you wanted the 20th term in this sequence, all right, the 20th term out here in this sequence would be 2 times 20, which is 40. All right, because of this formula right here. Now, a recursive formula. Is written when the next, well, no, not when the next, when, two things here, when you know the first term, and the next term is related to the previous term. So if you look at a sequence like 133, 130, 127, 124. Seeing the pattern? They're going down by 3 each time, right? All right. Each term after the first term is equal to 3 less than the previous term. A recursive definition for this sequence contains 2 parts: the initial condition here is that a sub 1 equals 133. The recursive formula in this case, it would be a sub n is equal to n minus 1 minus 3. There's supposed to be another a right here. And this is a rough morning for me. A sub n equals a sub n minus 1 minus 3. And these terms are also numbered as well. So here's your first term in the sequence, second, third, fourth. Problem with this sequence is you need to know the previous term or the value of the previous term to get the next term. All right, so like here, if you were asked to find the 5th term, your a sub 5 is equal to your a sub 5 minus 1 minus 3. Well, your a sub 5 is equal to your a sub 4 minus 3. So your a sub 5 is equal to your a sub 4, your 4th term in the sequence, is 124 minus 3. So again, your a sub 5 is equal to 121. But you didn't need to use a formula to figure that out. But those are the 2 differences: explicit formulas and recursive formulas. When you're asked to write a recursive formula, you always list the first term, and then you list the formula that relates the terms. The next term is related to the previous term. This is how you write the previous term when you're writing a formula. You write it as a sub n minus 1. So you could also read this as a term in the sequence is equal to the previous term minus 3. And that's how you write previous term. Now, I'm going to tell you, these recursive formulas are much easier to write. The explicit formulas, when you're doing your assignment today and you're writing these explicit formulas, try not to get too frustrated. They're hard to write, okay? They take a lot of trial and error. But you just have to understand the difference in the 2. And you got to see, I'm going to, I'll freeze the assignment up there, but I want you to take a picture of the answers before you start the assignment. And when you're writing your formula for each sequence, I want you to give it like a decent effort before you look at the answer, because then there can be some learning going on. If you just go straight to the answer, you're not going to learn anything. All right. So let's go back to writing an explicit formula. Or actually, let's do this right here. First set of problems you're going to have today, the directions are going to say, find the first 6 terms of each sequence. And if you're given a sub n is equal to 3n plus 2. First 6 terms in each sequence. So we're going to number these terms. We got term 1, 2, 3, 4, 5, 6. Term 1, a sub 1. Our a sub 1 is equal to, guys, I'm sorry, this n is not in subscript. It's just in regular right here script. This is 3 times 1 plus 2. So our first term is going to be 3 times 1 is 3 plus 2 is 5. Our second term, our a sub 2, is equal to 3 times 2 plus 2. 3 times 2 is 6 plus 2 is 8. Our a sub 3 is equal to 3 times 3 plus 2. And 9 plus 2 is 11. And then usually after the first couple, you're going to get the idea of what's going on. So 3 times 4 is 12 plus 2, 14. 3 times 5 is 15 plus 2 is 17. And 3 times 3 times 6 is 18 plus 2 is 20. And I got to pause again. All right. That's going to be the first part of your assignment today. Second part of your assignment. Write a recursive definition for each sequence. So we got 80, 77. $74, $71, $68, ... All right, recursive is when the next term is related to the previous term. So in this case, in a recursive, you know the first term. So your a sub 1 is equal to 80. Now, when you're writing your definition will look like this. It'll look like a sub n is equal to, which means a term in the sequence is equal to its previous term, which is a sub n minus 1. And what's going on here? Yeah, exactly, minus 3. All right, that's what they mean when they ask you to write a recursive definition for each sequence. You're going to list the first term, and then you're going to write a formula as each term or as each next number relates to the previous number. And then the third part of the assignment, this is the most or the hardest part. Write an explicit formula. For each sequence. Then list the 10th term. All right, so an explicit formula, we got 4, 5, 6, 7, 8. Let's see, let's go down a little bit here. Now, you got your term numbers. You got term 1, 2, 3, 4, 5. When you're writing an explicit formula, your formula is all based on the position of the number in the sequence. And what you're doing is you're using the numbers in red to come up with the numbers in black. And that's the relationship that you're looking at. Okay? You see the relationship? Does anybody see a relationship yet? What do you see?
Let's say if 1 and then that's 4, it's always adding 3.
Perfect. That's exactly what you need to see. Remember the other numbers, how you looked at it left to right, like you're used to reading? That's recursive. When you get to explicit, you got to look vertically. What do I do to this top number to get the bottom number? All right, that's the hard part of explicit, is now you don't read the way you normally read. Instead of reading horizontally, you're reading vertically. So this is what your formula looks like. It's A sub n. It's A sub n is equal to. You refer to these numbers up top as n. So it's going to be n plus 3. So your A sub 10, your 10th term in this sequence, is going to be equal to 10 plus 3. So your A sub 10 equals 13. Can y'all handle that? All right, so your practice for today is on page 569. Problems 7 through 22. We're going in the basket, or we are emailing a picture. If you're an e-learner and you don't have any questions, you're excused at this time. If you are an in-classer, give me 1 second and I'll get these. I'll get this info up on the wall for you.